All right, in this lesson, we are simplifying rational expressions, and then we are going to get into multiplying and dividing rational expressions. Okay, and so we are going to start by simplifying each rational expression, and you simplify rational expressions by basically canceling any common factors that are on top and bottom. So looking at this first example, we have 60 over 12, which we know is just 5. And then if we have 3 copies of x being multiplied on top divided by 1 copy on bottom, we know one of them is going to cancel, leaving us with just 2 copies. And so this whole thing simplifies to 5x squared. And this is just a review from rules of exponents. We'll get into some different kinds of problems in a second. And so number 2, also a review from rules of exponents. And so first I am seeing 70 over 100. And so we would want to simplify 70 over 100 to 7 over 10. And then remember, your answer is always going to be one rational expression, so only one fraction bar. And then 1 copy of x, and we have 2 copies on bottom. And so this one's going to cancel, leaving us with just 1 copy on bottom. And so our final answer would just have a 7 on top and then the 10x on bottom. Okay, next we have some trinomials. We have some expressions with multiple terms. And so you have to be careful here. And so notice these first 2 examples didn't have any plus or minus signs. Now we have some plus signs, some minus signs. And so what I see often is people see x over x squared and they start trying to cancel things. You cannot cancel division and addition or subtraction. And so you can only cancel common factors. Factors means multiply. And so what you want to do with these expressions is factor everything you can. And so the numerator is just a linear factor with no GCF, so that's not factorable. On bottom, that's a quadratic trinomial that factors to x plus 7, x minus 3, just looking for 2 numbers that multiply to negative 21 but add to 4, and so positive 7, negative 3. And so now I have a factor of x plus 7 on top and a factor of x plus 7 on bottom, and so those factors would cancel, leaving me with nothing on top. Whenever there's nothing on top, there's 1 as a placeholder, and then x minus 3 would still be on bottom, and so that would be our final answer. Be careful not to write 0 on top. If everything cancels, you're left with a 1. Okay, on number 4, I see plus signs and minus signs. So we want to factor everything that's factorable. And so looking at the numerator, I'm looking for 2 numbers that multiply to 5, but add to 6. Multiply to 5, add to 6. That is 5 and 1. Be careful not to say 2 and 3. 2 and 3 don't multiply to 5. They multiply to 6. And so this factors to x plus 5, x plus 1. And then on bottom, we have an x plus 1. Okay, and so the factor x plus 1 cancels with the x plus 1 on bottom, leaving me with just an x plus 5 on top. And if nothing's left on bottom, you could write the 1, but we don't typically do that. That would not be simplified. Just like if your answer was 5, you wouldn't write it as 5 over 1. Whereas if your answer was 1 over 5, you wouldn't change that to 5. And so ones on top have to stay, ones on bottom do not stay. Right, next up, looking to factor anything that's factorable. As soon as you see minus signs, you know you need to factor. And so looking at the top, that is linear, meaning degree 1. There's no exponent other than 1, but there is a GCF of 4. Watch out for GCFs. And so if I factor out the 4, that leaves me with an x minus 2. And then on bottom, we have another GCF situation. Both of these have an x. Okay, and so when you factor out the GCFs, you're going to see that you do have a common factor, x minus 2, x minus 2. So sometimes common factors are hidden by a GCF, so always watch out for those. Okay, next we have a quadratic trinomial on top and a quadratic trinomial on bottom. And so we're going to factor both. And so on top, two numbers that multiply to negative 24 and add to negative 2 are negative 6, positive 4. So that factors to x minus 6, x plus 4. On bottom, we're looking for two numbers that multiply to positive 36, but add to negative 12. That would be negative 6, negative 6. And so you could write that as x minus 6 quantity squared, but it's going to be better to just write out both factors because you can only cancel one factor. You only get 1 for 1. You don't get 2 for 1. And so only one of the x minus 6's cancel, leaving you with an x plus 4 on top and an x minus 6 on bottom. All right, looking at number 7, anytime your x term is not written first, you always want to rewrite it to where x is first. And then if you have a negative on the leading term, you always want to factor out a negative 1. And so I'm going to factor out a negative 1 from the numerator, leaving an x plus 4. And then on bottom, we're looking for two numbers that multiply to 8 but add to 6. That would be 4 and 2. And so we have an x plus 4 on top and bottom. And so don't lose your negative. And then we have an x plus 2 on bottom. A lot of people lose their negatives. All right, on number 8, we have another GCF situation. We can factor out an x. And then on bottom, two numbers that multiply to positive 20 but add to positive 9 are positive 5, positive 4. And so in this case, nothing cancels. X minus 5 and x plus 5 are not the same, and so you cannot cancel those. And so in this case, we are as simple as it can get. Don't try to force things to cancel if they're not canceling. Right, the other part of this is identifying any x values for which the expression is undefined. And so remember, a rational expression is undefined if you have a 0 on bottom. If you have a 0 on bottom of a fraction, it's undefined. And so that n on top could be any number. It could be 5 over 0. It could be 100 over 0. Anything divided by 0 is undefined. Where if 0 is on top, that's okay. That just equals 0. So 0 over anything is 0. Anything over 0 is undefined. And so looking at the first problem, we just want to set the denominator equal to 0 and solve. And so dividing both sides by 12, x cannot equal 0 would be a restricted value. A restricted value is an x value that makes the expression undefined. And so later we'll be calling these domain restrictions. So if you want to go ahead and label that a domain restriction, that's what we're doing each time we find the values of x for which the expression is undefined. So similarly, if we look at our denominator, we kind of want to look at the original denominator so we don't lose factors. And so 100x squared. And so divide both sides by 100, you still get 0. Square root both sides, you still get 0. So x equals 0 is the domain restriction. And so we represent that with an equal sign and a slash through it. X cannot equal 0. Okay, be careful here. Go to the factored denominator before you canceled things. And so here we're setting x plus 7, x minus 3 equal to 0. And so in that case, x cannot equal negative 7, x cannot equal positive 3. Those are our two domain restrictions. Here we just have an x plus 1 on bottom, and so x cannot equal negative 1. Here we have x and x minus 2, and so in the first case, x can't equal 0. Second case, x can't equal 2. Here we have a repeated factor, and so x cannot equal 6 is the only domain restriction since it's repeated. It has a multiplicity of 2. Next, we have x cannot equal -4 and x cannot equal -2. Remember, you always take the opposite of what you're seeing in those parentheses to get your actual solutions there. Here, x cannot equal -5 and x cannot equal -4. And so this is going to be an extremely important concept throughout this entire unit on rationals, is finding these domain restrictions. It affects your equations, it affects your graphs, and so we'll keep talking about this throughout the unit. Okay, and so as an added extension to this lesson, we are going to be multiplying and dividing rational expressions, but the hardest part is just simplifying your final answer, which we've just done. And so looking at this first example, I'm going to create an analogy with just fractions, numerical examples, and then we'll look at function examples. And so when you multiply fractions, you multiply the numerators and multiply the denominators. You multiply across. And so multiplying fractions is actually easier than adding and subtracting. We'll do that next time. But for here, you don't need a common denominator. You just multiply. And so if you were to multiply 15 times 2, you would get 30. Multiply your 8 times 35, you get 280. But you don't want to leave your answer like that. If you can simplify the fraction, you absolutely want to. And so this simplifies to 3/28. Okay, and so it's not wrong to multiply these fractions that way, but sometimes the numbers can get really large, like 8 times 35. That's pretty big to do in your head. And when we start working with functions, you're not going to want to do it that way. You're going to end up with degree 3 and degree 4 polynomials that are going to be very difficult to simplify. And so a better approach to this is to factor everything that's factorable. And so 15, looking at our first fraction, this 15 can be factored to 3 times 5. 8 can be factored to 2 times 2 times 2. Just looking for all their prime factors. 30 is 3 times 10, which is 3 times 5 times 2. And then, oh, not 30, it was 2. Sorry, I was looking at the wrong thing. Undo. And so we just want the 2 here. And then 35 would be 5 times 7. Okay, and so remember, we're multiplying the numerators and multiplying the denominators. So everything on top is getting multiplied, everything on bottom is getting multiplied. And so we can write it as one fraction. And then remember, any factor on top can cancel with any factor on bottom. And so I see a 2 on top and a 2 on bottom. You don't get 2 for 1, so only 1 cancels. And then I also see a 5 on top and a 5 on bottom. And so that leaves me with just a 3 on top and then a 4 times 7, 28. So we get the same answer, but it just keeps the numbers small to just factor everything and cancel. And so that's the method we're going to use for these functions. We're going to factor everything that's factorable and then just cancel everything that's on top and on bottom. And so this example, we have f of x and g of x. And so the first thing I'm going to do is factor everything in sight. So f of x can factor to x minus 2, x plus 1. And then on bottom here, we have to figure out two numbers that multiply to -4, but add to -3. That's -4, positive 1. And because a isn't 1, we have to split the middle with those numbers. And then factor 2 at a time. So x minus 2, x minus 2. And so that factors to x minus 2 to x plus 1. And then we're multiplying by g of x. So for g of x, 2 times -3 is -6. Two numbers that multiply to -6 and add to -5 are -6 and +1. Split the middle and factor by grouping. So we can factor out a 2x. We can factor out a 1. So x minus 3, 2x plus 1. And then on bottom here, that's just a GCF situation. So factor out an x. And then remember, we're going to multiply the numerators and multiply the denominators. And so we can rewrite this as a single fraction. In fact, if you just want to extend your fraction bar, this is all just one big fraction. Okay, all these factors, any factor on top can cancel with any factor on bottom. It doesn't matter which original function it was part of. And so I see an x plus 1 on top and bottom. I see a 2x plus 1 on top and bottom. And so all I am left with is an x minus 3. Oh, there was an x minus 2 on top and bottom. And then so all we have on top is an x minus 3. And all we have on bottom is the x. Don't lose those GCFs. They get lost. And so x minus 3 is our numerator, and then x is our denominator. And be very, very careful not to cancel these x's. And so remember, this minus sign and this division sign, they don't cancel each other out. You can only cancel common factors. Factors means multiplication. If this minus sign was times, we could cancel the x's. But here, we cannot cancel the x's. I see that way too often. All right, and so with division, it's very similar. We just have to flip the second fraction and multiply. So you multiply by the reciprocal. And so some of you may have learned keep, change, flip. You keep the first fraction, change your sign to multiplication, and then flip your second fraction. So keep, change, flip. And so keep the first fraction, change to multiplication, and then flip your second fraction. And so now we can multiply the numerators and multiply the denominators, or we can do the same thing we did in the last problem where we factor everything in sight. And so 3 over 5 times, and then 25 is the same as 5 times 5. 6 is the same as 2 times 3. And so anything on top can cancel with anything on bottom. And then we have a 3. And so we are left with a 5 over 2. Okay, so same thing as multiplication. You just have to remember to flip the second fraction, not the first. You don't get to choose. Okay, and so now we are finding f of x divided by g of x. And so first step is factor everything in sight. So f of x would be x minus 3x plus 2. And then we would have x plus 4, x minus 1. Change to multiplication. And then we're going to have to flip g of x. I'm going to factor him up here. So two numbers that multiply to positive 6 and add to negative 5 would be negative 2, negative 3. And two numbers that multiply to negative 8 but add to positive 2 are 4 and negative 2. Okay, and so now we have to flip that. The x plus 4, x minus 2 would be on top. And you could cancel right there, but I always wait till the end. And then x minus 2, x minus 3 would be on bottom. Okay, so now it's the cancellation game. Just cancel anything on top with anything on bottom. X minus 3, x minus 3. We have this x minus 2, x minus 2. We have an x plus 4 and an x plus 4. And so all we're left with is x plus 2, x minus 1. And so x plus 2 is on top, x minus 1 is on bottom, and that would be your final answer. Don't cancel the x's. Remember, division can't cancel with addition and subtraction.